All right, today we're doing section 3.2, day 1, which implies there will be a day 2. We are splitting the section up over 2 days, so you'll notice you'll have less problems for homework tonight. It's because you'll be finishing the rest tomorrow. Both days we are learning to solve systems algebraically, so without graphing. We're going to do some math with them, solve them that way. The two methods are substitution and then elimination. Elimination has a bunch of different names. People call it combination method. People call it the opposite method. But elimination method is what I'll call it. And today's substitution. All right. So here is how we do the substitution method. The first thing you want to do is solve one of the equations for one of its variables. Then you want to substitute the expression from step 1 into the other equation and solve for the other variable. Substitute the value from step 2 into the revised equation from step 1 and solve. It sounds like a lot. It's actually not that tricky. Substitution method works great, especially if one of the variables is already by itself. So if step 1 is done for you, you definitely want to do the substitution method. Feel free to write this in your notes. It is, however, in your book. So if you want to do an abbreviated version and then the long version's available in your book, that is fine with me. So the first thing you want to do when you're solving using the substitution method is to get one of the variables by itself. You can decide which one. Anyone see a variable that's like almost by itself? Yeah, the y in the first equation. So if I want to get that y by itself, I could subtract 2x. So I'd have negative y equals negative 2x plus 6. Divide, divide. So y equals 2x minus 6. I'll give you guys a second to catch up. That was step 1 from those steps we just looked at. We isolated one of the variables. Step 2 says to take that expression, so I'm going to take this expression that y equals, and I'm going to replace the y in the other equation with that value. So now I have 2x plus 2, but instead of y, I'm going to write 2x minus 6 equals negative 9. All right, to solve this, we'd have to distribute. So we have 2x plus 4x minus 12 equals negative 9. All right, combine your x's. You get 6x minus 12 equals negative 9. Solve it from there. So I'm getting that x equals 1/2. I am halfway done. Once you know what one of the variables is, plug it into the equation where you had the other variable by itself. So if I plug it back into here, I have y equals 2 times 1/2 minus 6. That's 1 minus 6, which is negative 5. So I am coming up with the solution 1/2 negative 5. Now that was a lot of steps, and I could have definitely made some mistakes. How can I check to see if this is truly the solution? Plug it back in. If I plug it in here, I'd get 1 minus negative 5. That's like 1 plus 5, which is 6, so that one's true. Here I'd get 1 minus 10, which is negative 9. So, yep, this definitely checks out. Any questions for me? All right. First step, get a variable by itself. Anyone have a preference? The second x, good, because we could just add 2y to both sides. So x equals 2y minus 7. I take this value. I plug it in for the x in the other equation. After you plug it in, you should notice that all your x's are gone. If they aren't, you did something wrong. Okay, the whole point is to get just one variable. So now we have just y's, and we can solve from here. So 7y. When you add 14 to both sides, you get 21. Y is going to be 3. Once you know that y is 3, what do you do with it? Plug it back in. The easiest place to plug it in is right here, because x is already by itself. So it's going to be 6 minus 7. So x is going to be negative 1. So the ordered pair here, negative 1, 3. Let's double check. If I plugged it in here, I would get negative 2 plus 9, that is 7, so it works. Here I would get negative 1 minus 6, which is negative 7, so this definitely works in both. What are your questions? Okay. Which variable would you like to get by itself? There's a couple options here. Y, which Y? Oh, now I'm torn. I hear both. Let's just do the top. You could do the bottom. Same thing. So I'm going to add 2x to both sides, right? So y equals 2x. Pretty easy. Now I'm going to plug that 2x in for the y in the other equation. So since I got y by itself in the top equation, 2x needs to go into the second equation. So that would give me negative x plus 2x equals 2. That just gives me x equals 2. Pretty simple. Plug it back in right here. So y equals 2 times 2. 4. Pretty simple one. Of course, we can plug it in to check. This would give me negative 4 plus 4 is 0. That's true. This would give me negative 2 plus 4 is 2. That's also true. Any questions? All right, what variable should we get by itself? One's already by itself, so step 1 is done for us. We can just take 3x minus 7 and plug it in right here. Don't forget to distribute here. If you're plugging in an expression for the x, everything in that expression needs to be multiplied by the 5. So make sure you keep the parentheses where they need to go. It's going to be minus 15x plus 35 equals 9. So negative 13x equals negative 26. I'm getting x equals positive 2. Anyone agree? Great. You can plug it back in. The easiest place is where y is already by itself, right here. So I'd have y equals 3 times 2 minus 7. 6 minus 7, negative 1. So 2, negative 1 is what I think my solution is going to be, but of course, I'm going to double check. So if I plug it in right here, I'd get 4. 2 negatives is a positive, so 4 plus 5 is 9. That's good. If I plug it in back here, I'd get negative 1 equals 6 minus 7. That one's good too. So this is definitely our solution. What are your questions? All right. Number 5. This is another, I don't know if they're easier, but they definitely go well with substitution because the first step's already done for you. X equals 2y plus 1, so I'm going to go ahead and just replace that x with 2y plus 1. Distribute and solve. So negative 6y minus 3 plus 4y equals 1. I'm not talking a lot about the solving equations. I'm assuming you guys are experts. Again, I'm sure you were at one point. So I'm getting negative 2 for y. Plug it back in. And I'm getting, whoops, that should be an x. Can't have two y values. And I'm getting negative 3 for x. So I think it's negative 3, negative 2. But let's double check. When I plug that in, I would get negative 3 equals negative 4 plus 1 over here. That works. Over here you'd get 9 minus 8, or 9 plus negative 8 gives you 1. So it definitely works. Awesome. I went through that one kind of quickly. Anyone need some more explanation on any step? All right, how do you guys want to start number 7? Get the y by itself in the bottom. Good. So I'm going to subtract 3x from both sides. I get y equals negative 3x minus 4. Plug this in for the y in the top. So I get 4x plus 5 times negative 3x minus 4 equals 13. So it's going to be negative 11x equals 33. So x is negative 3. We can find y by plugging it back in right over here. So y equals negative 3 times negative 3 minus 4. 9 minus 4 is 5. So I think it's negative 3, 5, but let's plug it in and check to see if it works. Plug it in here, we get negative 12 plus 22, no, plus 25. Yeah, that works. Plug it in down here, you get negative 9 plus 5. Yep, that works. We're good. So not a special case. I was hoping to find some special cases towards the end, but this one just had one solution, so we're good. Any questions? Let's see if 8's a special case. Just might be. How would you start this one? Get y by itself. Top y, I assume. So let's add 2x to both sides. So from the top equation, I'm getting y equals 2x plus 6. I'm going to take that. I'm going to plug it in right there. I'm going to give you guys some time to catch up. I don't want you to miss the good stuff. All right, so when I plug it in, I'm getting 4x minus 2 times 2x plus 6 equals 5. Distribute. 4x minus 4x minus 12 equals 5. What happens to those 4x's? Yeah. So I have negative 12 equals 5. This is where you ask yourself, is this a true statement or a false statement? False. If it's false, your answer is no solution. If we looked at this graphically, they would be parallel lines. They would never intersect. No solution. This is a special case. When all your variables cancel out in the substitution method or in the elimination method that we're looking at tomorrow, it's a special case, and you have to ask yourself if what you're left with is true or false. Questions? All right. Here's number 9. I know, tricked you guys. True. All right. How do I start this? Yeah, let's get that top y by itself. So I'm going to subtract 3x. So I'm going to have negative y equals negative 3x plus 4. Change all your signs. So 3x minus 4. Take that, plug it into the other y. So negative 9x plus 3 times 3x minus 4 equals negative 12. After you distribute, you can probably see what's going to happen here. Yeah, those 9x's are going to go away because one's positive, one's negative. I'm left with negative 12 equals negative 12. Ask yourself, true statement? False statement? True statement. If it's true, your answer is many solutions. All right, if we looked at these graphically, they would be the exact same line. You can see that if you're just looking at the equations, it looks like if you took the top one and multiplied it by negative 3, you'd end up with the bottom one. So yeah, they're the exact same line. Many solutions. What are your questions? All right, here's your homework. Like I said, we're breaking the section up over 2 days, so this is not a ton of problems. But please get them done tonight so that you can focus on the other method that we're going to learn tomorrow. Any questions for me?